Okay, let's say we've set up the oscillator, we've opened up the lungs, we've recruited them, and now we're oscillating a baby and we have a period of stability. A few important things to know about oscillation. Here's the thing. We should be on a different screen. That's one thing. We have a nice screen set up for oscillation. And the screen will show us the FiO2, the mean descending pressure, the tidal volume being achieved in oscillation, and your delta CO2, and of course whether there's any air leak. So these are recorded things, and these are set things along the bottom. Your FiO2, your frequency of oscillation, your IE ratio in oscillation, and your descending pressure, your mean descent, and your amplitude. Now, I'll tell you now, this is set up for a 1 kilogram baby, as all these demonstrations are. The tidal volume in oscillation is about 1 to 2 mils per kilogram. So if you've got a 1 kilogram baby, I'll tell you now, this machine is telling me 0.7, we're not achieving an adequate tidal volume in this baby. The other thing is, your delta CO2 is a very good indicator and a very good parameter to be aware of. The delta CO2 tells you your effectiveness of CO2 clearance. If that's in single figures, or you're not achieving any CO2 clearance. And your delta CO2 is actually a matter of, it's a product of your frequency times your tidal volume squared in oscillation. So it's very low. So I'll tell you now, looking at this baby, and this is the dummy lung, it's nearly quivering. So everything that I know about this baby and this setup is that this baby is not clearing the CO2 properly. So in order to clear CO2, and this would be linked with a blood gas that would show a high CO2 and acidosis, the first thing we reach for is your amplitude of oscillation. So currently it's set here at the minute at 41. Well, I'm going to crank that up. And I'm going to turn it up quite quickly because I know I want a tidal volume in oscillation of 1 or 2 mils per kilogram. So I'm turning that up now from 40 to 60. It's a 1 kilogram baby. And there is a little response, so that's good. I've got some response. But let's say the baby's very acidotic with a high CO2. It's not a great tidal volume still. And the delta CO2 is only 14. These are very, very low figures. So I'm going to turn up my amplitude further. And this is what you do. You turn up your amplitude, and if necessary, you max out your amplitude in order to blow off CO2 in oscillated babies. Now I'm doing this probably a little bit gung-ho, but it's because I'm confident in that I'm looking at the baby's chest wiggle, and I'm looking at the recorded screen to say, am I achieving a tidal volume, which is dangerous? And they're really very, very low, so I'm not. So maximizing the amplitude is really, really important for CO2 clearance. Once you've maximized your amplitude, if you're still not clearing your CO2, and all things being equal, you don't have a pneumothorax, your baby is well sedated and whatnot, you will sometimes, but uncommonly, you will sometimes have to turn down the frequency of oscillation. So a preterm baby we set at 15, but sometimes we'll find that if we turn it down a hertz or two, we will allow more time for the oscillation to work, and that allows more time for the in and out of ventilator breaths. So I've turned down the high frequency from 15 to 14 hertz. Am I achieving anything in terms of VTHF tidal volumes? A little bit, and the delta CO2 is up to 20, so that's made a difference. For the purposes of demonstration, I'll turn this down one more. And let's see what happens here. Give it a wee second. The delta CO2 has come up to 23. Manipulating the frequency and oscillation is a very powerful means of clearing CO2, but we largely want the consultants to be directing that sort of thing, or if you're not comfortable with the machine. So having dropped the frequency to 13, I've got a tidal volume and oscillation of 1.5. Let's say I still want to get to 2 mils per kilogram. I'll drop the frequency again. And let's see how are we achieving this now. This is a dummy lung, so it's not entirely physiological. That's maybe as good as it can get, but it's gone up. So manipulating CO2 Once you've got your lungs open, the most important thing is to manipulate your amplitude. That's the chest wiggle factor, and that's by manipulating the amplitude. With regards to oxygenation, the main way to manipulate oxygenation is your FiO2 and your mean distending pressure. And that's what we did whenever we showed you how to recruit the lungs at the time of putting a baby onto oscillation. But if you find that the baby is starting to drop their saturations and you've checked them for pneumothorax and you don't think you're over distending them, the first thing to do is, of course, turn up your FiO2. But really, if you're having to turn up your FiO2, you should ask yourself the question, do we need to recruit these babies again? Do I need to increase my mean airway pressure for a period of time? So I'll stop there.